Hi, everybody. We're going to quickly go over our topic 1 review, day 2. We're going to be going over the first problem in every single section from each slide. So some slides only have one section, some slides have more than one. That's why I say each section. Let's go ahead and jump right in. We're starting with 1-7, parts of an expression. The instructions say, highlight the terms in each expression, then count the terms. Our first problem says 98 plus 16 minus 101. In your book, it describes that a term is anything that is separated by an addition or a subtraction sign. Therefore, in this specific problem, we would highlight 98, 16, and 101. In my purple box that I would have in my slides, I would type in 3 terms because I highlighted 3 terms. The book does specifically say that a term is only separated by an addition or a subtraction sign, which means if I had this written as 101z, so it was a number multiplied by a variable, that together is its own term. It has to be separated by either an addition or a subtraction sign. Okay. Still on 1-7, it says, highlight the coefficient, then identify the factors. In your book, the coefficient is described as the number that is multiplied to a variable. So in this problem, our coefficient would be 12. Now this entire problem is a product. A product is when you multiply 2 things. Usually we think of products as multiplying 2 numbers. In this case, you're multiplying a number and then a variable. And whenever we're talking about factors, those are the 2 things we multiply to make the product. Therefore, in this specific problem, the factors of 12p are 12 and p. So 12 is the highlighted coefficient. 12 and p is what I would have typed in that purple box, as those are the factors. One dash 8, evaluating algebraic expressions. It says evaluate each expression for x is equal to 3, 6, and 10. And the first one is 2x squared minus 1. So I'm going to start and the first number I will be plugging in is 3. So for x to equal 3 first. I still need to follow my order of operations. That would be the PEMDAS or PEMDAS. If I follow these rules, I will see that the first thing I need to do is parentheses. The only operation within my parentheses are the exponent, which is also the next thing that I need to solve. So I will have 2 times 3 squared is the same thing as 3 times 3 minus 1. 3 times 3 is equal to 9. I can next do 2 times 9. That would be the next order, is multiplication or division. 2 times 9 is 18. And my last operation, which also happens to be the last one for PEMDAS, subtraction. 18 minus 1 is 17. So in my first purple box, I would be writing 17. I'm going to resolve this problem, so I'm going to reset it up. This time I will be doing this for x is equal to 6. Just as I did before, 6 squared is the same thing as 6 times 6. Six times 6 is 36. Two times 36 is 72. Lastly, I subtract and I get 71. 71 would go into my second purple box. Lastly, I'm going to write this one last time. Solving for x is equal to 10. Ten squared is the same as 10 times 10. A quick trick, 10 squared, anything with a base 10 with any exponent, that exponent tells you how many zeros you're going to have. So using that logic, I will have 2 zeros. You might also just know that 10 times 10 is 100 due to your multiplication chart. However, you need to get there. 2 times 100 is 200. 200 minus 1 is 199. And that would go in your last purple box. One dash 9. Find the cost of 4 pounds, 5 pounds, and 10 pounds of apples. For 1 pound of apples, it costs $2. For 2 pounds, 4. For 3 pounds, 6. Now there are a few patterns that I could notice here. For starters, if I'm just looking at the price is being increased by $2 for each of these. So I went $2, if I had another $2, $4, if I had another $2, $6. However, another pattern that I can see is that if I look at the apple weight and I compare it to the apple price, the price of the apple is equal to 2 times the weight. So if I use the equation P equals 2W, I will be able to fill in the remaining boxes. I could also add the $2. So with 4 pounds, if I plug 4 pounds in here, 2 times 4 is equal to 8. If I add 2 to 6, I get 8. Plugging 5 in here, 2 times 5 is 10. 8 plus 2 is 10. Now, the reason why it's important to figure out what the exact pattern is, in possibly multiple ways, is when it skips here. So each time before we were only adding 1 pound. Now we're skipping from 5 pounds to 10 pounds. So adding 2 is not going to get us to the correct answer. So plugging 10 pounds in here, 2 times 10 is 20. (1-10) simplifying algebraic expressions. It asks us to simplify 2x minus 9 plus 9x. Now I choose to do this in colors so that I can help my brain identify the like terms. Here I have 2 terms that involve x's. 2x and the plus 9x. And I have one more term, minus 9. If I rewrite this so that my like terms are closer together, it can help me to solve and get to my final answer. As I can see, I only have one term that's in green, so it has no other like terms. I don't have anything to combine. I have 2 terms in this orangey brown color, 2x and 9x. Between them is a plus sign, so to combine these like terms, I'm going to add 2x and 9x. 2 plus 9 is 11. 2x plus 9x is 11x. (1-11), the last lesson for topic 1. Writing equivalent expressions. Find the missing numbers or number. We have 3 parentheses x plus 3 and 3x plus blank. Now it's not being shown to you. In between this and this is the distributive property that was used. So we want to remember with distributive property, the number on the outside of the parentheses stays the same. We can separate out the terms that are inside the parentheses, and whatever operation is what separates the 2 now terms. Now I can start solving. So 3 times x is just equal to 3x, plus 3 times 3 is equal to 9. Therefore, in my box, which is gray, on your slides it is purple, I would type a 9. And I almost forgot one last problem. Use distributive property to write the equivalent equation 8x plus 12. So this is where we are going to want to move backwards. And when I say move backwards, I mean we are essentially given this equation. We want to move back to where it looks like this. In order to do that, we need to find a number that is a factor of both 8 and 12. If I were to write out my factor rainbows, I have 1 and 8, 1 and 12. I also have 2 and 4 for 8. I have 2 and 6 for 12. I have no other factor rainbows for 8. I have 3 and 4 for 12. Now, if I'm looking at my factor rainbows, I can see that there are 2 numbers in common here. 2 and 4. Therefore, either one of those numbers would work for finding an equivalent equation. So the first one I'm going to do is 2. If I take a 2 out of 8, I'm left with 4. I see that by looking on the other side of the factor rainbow. There's still an x. If I pull a 2 out of 12, I'm left with 6. My other option is 4. If I pull a 4 out of an 8, I am left with 2, and there is still an x, plus. If I pull a 4 out of a 12, I am left with 3. Both of these are completely acceptable, 100% correct. You only need to choose one of these to type into your purple box. All right, that was a review of topic 1, the second half of the topic. Have a great rest of your day.